an update for my car 2023, January 1st. So, Steve finished up the rotating assemblies for the first two motors. That's the GSL SE 3mm apex seals and the S4 NA rotors, 2mm for that one. And it's really interesting to see the differences of balancer to balancer to balancer when it comes to our sector of the industry, right? Like we'll have someone who is saying, I'm getting within this tolerance, I'm happy with this RPM, I have this race team that uses my stuff, whatever. When it comes down to units, the granularity and the effort put into making these engines balance and the tightness of the tolerance, I'm unbelievably impressed with what Steve and Ben did. Some people are measuring ounces per inch, which is like, we're talking about forces acting on an object away from a center line. So your inch is your center line, your ounces is your mass, essentially. And, if they're aiming for 0.1 of an ounce per inch, I believe it's a factor of 7. So 7 times further away versus if you're doing grams per inch. And then the inch standard itself is not always like a standardized measurement. If it's 3 inches, 4 inches, whatever it is. And I know there's an online conversion, you can look it up. But when someone is going for a fraction of a gram, not a fraction of an ounce per inch, it is a much, much tighter tolerance. So I just looked at like 3 or 4 different sheets that I've had from different balancers, and the tightness and tolerance is a factor of like 50. It's 50 times tighter when it comes to the forces acting on a car or an engine dynamically. So incredibly impressed. Thank you guys so much for doing awesome work. And on that, so I've got rotating assemblies done. John at Legend Motorsport is probably halfway into the planning and port shaping for the first motor. Now that motor is going to be a 25mm semi-peripheral port, CX Racing lower intake manifold modified. We dropped in a slug to downsize, and then now we've ported that into and shaped that runner. It's O-ringed, it's set up and ready to go for pretty much 40-50 pounds of boost. I have a bunch of effort put into the upper intake manifold on that side as well, so it's gone through. I did not do the there's like a media pass-through porting style that you could do for upper intake manifolds. I elected not to do that for this because I think at our power level it won't be a restriction quite yet, as we're focusing more for velocity and control, not for overall power output. So peripheral port, the street port on the primary is going to be something about a medium size, and then the secondary is going to be what I would call a constructive wave synced with the semi-peripheral port, Bridgeport. So constructive wave meaning that we're trying to time the semi with the bridge, and the sizing of the bridge is going to be according to the semi, and that overlap is going to be all in relation to that. So with the sizing of that, which will be somewhat of an aggressive bridge, but not too much to where we need to have We don't want to be splitting up airflow too much, okay? If we're adding a semi, that usually makes the Bridgeport less effective. When you have a Bridgeport, your focus is going to be on velocity of the Bridgeport, which is going to come in as a secondary pulse wave from the combustion event. So that's why I'm saying we're focusing on making a truly synchronized, constructive wave pattern for the Bridgeport stuff. John is all over it. He's ready to go. We've got balance rotating assembly, as I've talked about. We've got that set up. We've got the lower intake manifold set up. And as far as turbo stuff goes, that's already been installed, proven. Sensors are all put in place. So all of that's going to be, once the motor's back here, drop it in, plug and play. Someone's going to ask apex seals. I have a set of RA super seals that are 3mm that we sent out to RX Parts for Roan to do his 2 or 3 stage added to the RA super seal to make them hopefully even better. When John received them, he was like, it feels slick in your hand like oil light. So he was very impressed with that. This motor has 9 half-inch studs by Chip, and it has the rest of them are ARP 10mm stuff from Turblown. So we won't have as much clamp force as if we were doing a through stud on the block, which is very common on the REW blocks. That's always the way to go if you can get it solved and figured out, because that gives a true clamp without holding on the threads. You're actually holding it on nuts, which distribute the forces better. But when it comes to the fit of the bolts, they're much tighter than the past block, so I'm very happy with that. The GSLSE rotors have a huge benefit to them, which most people don't realize. The side seal is 1mm, not 0.7. So we're talking about longevity. We're talking about keeping things higher boost, and it's a higher compression ratio motor. So if we wanted to go all out, like boost only, safe, S4 Turbo 2 is the way to go. The fact that I'm trying to use this for a dual purpose street build is high compression, 9.5 to 1, and the thicker side seal should give us a better sealing and a better overall durability for the usage that I have, which is like mountain roads, long-term drives, stuff like that. There's a lot of reasoning behind it, and if I could go a 2mm seal on the GSL SE, I probably would have, as far as apex seal. That way I would have had all the benefits of the 2mm stuff, and none of the drawbacks. So we're more likely going to have higher RPM chatter with the 3mm apex seal, and I think that overall that's going to be a good package. I think that that's going to balance everything out. The turbo's really only rated to about 36 to 40 psi until it overspins. So because I have all the turbo speed sensing, and I personally know what overhead it can handle for beyond its RPM usability, I can kind of say, like, we'll give it a 15-20% overhead, and we can hold it at peak speed as much as we can. We go to optimize and say, here's what the turbo wants, and then we can overall figure out what we want to do with that. So the drive-by-wire blow-off valve on the compressor side will help maintain that without surge in the turbo, and that's very much the modern approach now. It's anything we can do to control turbo speed without a loss and without surging is a win. So the block should be here, I'm assuming, within the next month. I know this is the first motor of Legend Motorsports for the year, but I told John, take your time, go through everything. We've got a brand new oil pump, we've got brand new irons, brand new housings. It's a brand new block. There's nothing else around it. So once it gets here, I'll go install my flywheel and my spec twin disc and drop her in place and pretty much just start throwing everything together. I've got Weird Performance has my differential from Oiskaiken, and I'll be pulling the third member for the back of the car. And once we've got that, we're doing a solid pinion on the back with a modified Spicer 1350 or Dana 1350, I think it is, Spicer. So once we have that figured out, Oiskaiken put in place, then I can order up my drive shaft from Mark Williams. And now it's a 1350 front and rear, 3-inch chromoly drive shaft, designed to just handle the world. It's going to handle all the power and be reliable and then be relatively small. As much as I would have loved to go 4-inch, there simply isn't room in the FB chassis. So couldn't go carbon fiber because it'll melt. The seal they use for bonding any sort of a bonded drive shaft will always fail if it's near an exhaust. And rotary exhaust and long-term driving, it's not worth having a more flexible graphite flex type drive shaft if you have a bonding material that fails at 250 degrees Fahrenheit. And knowing how tight all the exhaust is up in there and how the exhaust is sitting below and heat would be resonating upward to the drive shaft, it just seems like a recipe for disaster. So even though I should only worry about the ends of the drive shaft being hot, because that's where the bonding material is focused, I don't think that it would be the smart choice. So I'm electing to go with the tried and true chromoly stuff from Mark Williams. A lot of different companies that I reached out to were not worried about temperature as much as they should have been. So I think I'll take a little bit of loss in performance and gain overall durability and lifespan. That's kind of the whole point of this build. So GSLSE, same thing. We took about 390 grams out of the rotor each, but we're still heavy by comparison to S4NA, S4 Turbo 2. It's still relatively heavy. It's about a pound and a half over what the total Semi would have weighed with a standard set of rotors. And so our RPM peak will probably be about 8,800 RPM. The other two motors, I'll probably be closer to 9,400, 9,500. So just kind of peace of mind. If I'm doing that, then the port timing and where we're focusing on things will be more mid-range punch. We're not going to try to rev this thing to 10 grand. It's not reasonable for a street car anyways. So our oil system is focused on that. Our turbo setup is focused on that. It's only a 73 millimeter turbo. So like there's no big dick power going up there. We're trying to get that thing spooled and gone. So a prime example is we put that turbo on Josh's car. I did. And even with boost leaks, he's getting 20 PSI by 4,000 RPM. So it is not a slouch. That thing just picks up and goes. And when it comes to the porting of that motor, his porting is smaller than what we're doing with a bigger Semi-P, which will inherently create a loss of response and power in the mid-range. So realistically, when we figure out street port, bridge, and crossover. The crossover point being where I can close the upper intake manifold and close off the semi and close off the bridge and focus on just the primary. This will create an area under the curve that rotaries haven't really been able to use. And besides PK out in Australia, I don't know if anyone else who's even done this. So, yeah. Actually, no. Carlos Lopez. Yeah. So we've got two proven rotary gurus have done a similar setup. And I think that that's going to be the party piece to the car, is the fact that we're going to have almost like if you guys ever watched the Diamond video of a BMW and the power band and how we do cam control, where torque is flat across a very large region. That's what we're trying to do in a low displacement rotary engine. So getting that together, I've got spark plug test coming together. I just ordered up the third competitor, which should be the cheapest option, but probably also the best made option. And we've got Denso, NGK. We've got this third one, which I will keep disclosed for now. So, well, I mean, you could probably have a hard time finding it, but it's Brisk. So, Brisk, NGK, and Denso. And I will have a comparison with the Fuel Tech box with the CAN bus feedback to kind of tell us how things are going and their true effective combustion quality. So once I get everything sorted and I've got the chassis sorted in the car and I've got, you know, all this tangible data, which there's going to be just mountains of, I can go through and start testing and R&Ding this whole process for what I think is a best combination for your setups. So hopefully you guys have seen what I've been doing so far with when I'm actually sitting down and consulting people. The builds that I consult seem to go together faster. I haven't had a single failure rate when it comes to the part selection, and the effectiveness of just saying use this combination and you'll have the power you want. It doesn't get better than that. Like, if someone asks for a specific, I have this need for my car, I can find that exact combination of parts for you to help to make it work. And yeah, I get so confused when I see people jumping steps. So in the next video I'll cover, it's rope brief E85 and recent problems of 2022 stuff and how I'm going forward with that. So here's my build recap, and wishing you guys a happy new year. So see you guys in the next one. Cheers.